Okay, what if we had something like that? What is the name of that molecule? So the first thing that you need to do is find the parent chain, which is the longest continuous chain. Okay? So I'm going to color code this. We could go 1, 2, 3, 4, 5. We could go 1, 2, 3, 4, 5, 6, 7. We could go 1, 2, 3, 4, 5, 6, 7. Oh, now we have a tie. What if I went this way? 1, 2, 3, 4, 5, 6, 7. Do you see how I am looking at every possible path that you can take? And so after going through every possible path, I can say, well, clearly I know that 7 is the longest one. Now, which numbering scheme of the 7s? We will get to that in a minute because there's a rule for that. But the first thing that you need to figure out is what is the longest continuous chain. And so that tells us our parent name. Okay, so what's our parent? I just write it down here. That would have to be heptane, because heptane stands for 7. Okay. Now, the next thing that I like to do is figure out we have to figure out the path. Which one are we going to take of all these colorful numbers? Okay. So let's erase them and start over again. And so we can see what's going on here. Okay, so we know if we go 1, 2, 3, 4, 5, 6, 7. And then we could go what? 1, 2, 3, 4, 5, 6, 7. Now with those two choices, the red and the green, we could have two other choices, counting in the opposite direction. True? Okay, so we have 4 possibilities here. Okay, so we found our parent chain. The next rule says you're going to number the longest continuous chain in the order in which you bump into the first substituent with the lowest locant number. The locant number are those numbers that I've drawn up there. Okay, those are saying the location. That's what the locant number means. Where's the location of the substituents? And we want to give the first substituent that we bump into the lowest number. So if we look at the red, and if we start from left to right, we see we bump into the substituent at what carbon? 2. But if we do the green numbers, when do we bump into the substituent?
3.
Okay, so let's make sure we understand this. With the red numbers there, why did I not number it from this direction? 1, 2, 3, all the way down? Because when do we bump into the substituent? We bump into if I'm looking at the red numbers and counting from the top down, I bump into the first substituent at carbon 6. But when I go from the bottom up, we bump into it at carbon 2. What do I mean by substituent? That's our substituent for the red numbers. And we bump into it at number 2. But what is our green substituent if we're using those numbers? It's this whole group. And what is that group called? Isopropyl. So which one do we use, the red numbers or the green numbers? And so you just go back. What's the rule? You bump into the first substituent with the lowest locant number. And so, students, when you get to this point in your analysis, you have red numbers and green numbers, and you're like, Dr. Lawrence, what do I do? There's a tie. I'm like, look at the list of rules, and it'll tell you how to break the tie. We're going to get get to even more ties, and it's going to get even more complicated, and there'll be rules to break more and more of those ties. But we just have to go down that list. And you have to just learn that list. So what is the correct name here is once we find the path that we want to take, okay, now we have to put the substituents. What's the substituent called? It's a methyl. Where is the methyl? 2. So 2-methyl. We're telling our readers, where is that methyl group? Well, it's at position 2 of the longest continuous chain, which is the parent chain. And now we just put this all together. Once you have found, we have another substituent. So we have to figure out everything that's coming off of that parent chain. So what would we call that guy? 3-ethyl. Okay. Now what we have to do, the next rule is when we write the name, we want to put the substituents first. And then we're going to put the parent name. So when we want to put the substituents first, which one do we put first? The one with the lower number? The one with the higher number? Lower number. No, that's not one of the rules. I know you haven't looked through them carefully yet, but that is a prime example of students making up their own BS. They're like, I want to do it this way. No. Follow the rules. The rule states when you name and putting the substituents in the name, you do it by alphabetical order. Okay? So E comes before M. So we would go 3-ethyl dash 2-methyl. Okay, so I've written down the substituents. And then we just tack on the parent name, which is what? Heptane. There's no space or anything. It just meshes on there. So we have a 3-ethyl, 2-methyl heptane. That's what you would call that molecule. Now, when you go and do nomenclature problems, especially on the exam, don't look at the answer choices, class. Just name it as if it was a free response question. And then once you find your answer, see if it's on the list or in the choices. Because, trust me, let's look at some incorrect answers that look so good. If you don't know the rules, you're going to get swayed really easily to pick a wrong answer. So what if I numbered it this way? 1, 2, 3, 4, 5, 6, 7. When I number it in that way, we have only one substituent. And where's that at? Carbon 3. So I would have named it 3-isopropyl heptane. And if someone looks at that answer and then if I traced it this way, I would get that answer. Yeah, you would, but it's wrong. You got to watch out for that. Okay? What would another answer choice be? Let's see. What if I numbered it in that direction? 1, 2, 3, all the way down. 4, 5, 6, 7. So what would we have here? We would have an answer choice of 6-ethyl, 6-methyl. So 6-methyl. No, we want to put ethyl first. Darn it.
6-methyl.
The ethyl is what? On carbon 5. 5-ethyl. 6 dash. Got to get our dash. Methyl heptane. Okay, all those answer choices look right. And why are they all? That's how it's going to be. Because I'm assessing, do you understand the rules and the process of looking at them? Okay? So we only have one correct answer there. And we need that. Because when we're in the literature and in the workforce, be saying the same thing. Or we will cause a lot of problems if we're not all saying the same stuff. So let's take a look at another problem here. How would you guys name... Yeah, how would you guys name this one? Since we have like 5 minutes left, I'll give you guys 2.5 minutes, and then I'll take the last 2.5 minutes. So name this molecule right here. One, two, three, four, five, six. Okay, 2.5 minutes. Name that molecule.
Yeah, he should be a very
And then Griffin starts looking through his bag and finds the dude's stuff still in it. So he took his calculator and personal blog and stuff in his not his bag. It's a little machine.
Please come back. I'd be like, I don't want to. Y'all can have it. Dr. Lawrence is going to take a picture of me when I have a video.
Not really.
I look sick.
Beautiful.
This was me after they did my COVID. It hurts. Like, I'm not happy.